Newton's first law, I'm going to be real careful now, is also known as the law of inertia. The state of motion of any object won't change as long as the net force on it is 0. Remember Dodgeball Guy?
Yeah.
Yeah?
That guy was funny.
Or Dodgeball Guy.
Crying
We don't
face.
have Mason to draw him sad face, so I'll do it instead.
Looks
Okay.
pretty much the same.
Except Mason's was a little more.
Okay.
How?
I could draw.
I'm not as much of an artist as Mason. Okay, Dodgeball Guy. Okay, when these two dodgeballs hit him, if they're going the same speed and they have the same mass as one another and they hit him exactly at the same time, will he fall in either direction?
No.
No. So if he's standing still and both dodgeballs hit him at the same time, he's not going to move. And when the net force, that is the sum of all forces, so this is a positive force because it is going to the right. This is a negative force because it's going to the left. Say it's plus
Positive
10 and
negative
minus
cancel
10.
each other out.
Plus 10 plus minus 10 is 0, right? So net force is 0. So there's no motion. Okay. This is also known as inertia. An object will resist a change in motion, or it resists acceleration. Okay. So an object's resistance to change in motion. So an object in motion tends to stay in motion, and an object at rest tends to stay at rest. That's why when I get home and put my feet up at the end of the day, then it's very hard for me to get up and do anything else, which is why I went to bed at 7:45 last night. So the acceleration of an object is equal to the net force acting on it divided by its mass. This should be obvious because last time, remember that we learned force equals mass times acceleration, right? Okay, so y'all are all in Ms. Boyd's algebra class, yes? Yeah? So how do I turn this equation into that equation? David?
Acceleration equals force divided by mass.
Right, so if we divide both sides by mass, we end up with F over M equals A. And really that A could be lowercase or uppercase. The A stands for acceleration. If you've got Dodgeball Guy and he's hit with a force of 15 newtons when it's in the negative direction, and he weighs 64 kilograms, which is 140 pounds. Negative 15 kilograms meters per second squared divided by 64 kilograms. Okay, so kilograms cancel out, right? Because you've got kilograms divided by kilograms. You're left with meters per second squared. That's acceleration, right? So what's 15 divided by 64? Who has a calculator? That's awesome. What's 15 divided by 64?
0.23475.
Negative.
But that's too many significant
Yeah.
figures.
Yes, it is. So how many significant figures do we need to have? Two. So it's just 0.23?
Yeah.
Okay. So now we know, based on the force that we know and his mass, we know what his acceleration is going to be. Is mass times the acceleration due to gravity. So you have 64 grams. If you have 64 kilograms of mass, that's literally how much matter there is in you. It's how much of you there is.
Okay.
So it really doesn't have anything to do with
How much you weigh.
how much you weigh. You have 64 if you weigh 140 pounds,
Although
which you don't. But if you did, you would have 64 kilograms worth of stuff. no matter where you go in the whole universe, you still have 64 kilograms worth of stuff in you.
Although,
Okay, so no matter where you go in the universe, as long as you don't fly apart or none of you falls off, you still have the same amount of mass. Which means that in the F equals ma equation, or A equals F divided by m, if you're hit by the same force here as you're hit by when you're standing on the moon, your acceleration will be the same. Your mass will be the same. You always have the same amount of stuff. So remember how a couple slides ago we talked about inertia and how inertia is your resistance? Your weight will be different.
So, but why?
But why? Okay, now I will explain why. Okay. Notice there's not anything in here about gravity. Okay. Right? So 627.2 is 627 newtons is the force of gravity on a person that weighs this much. Okay? Now, on Mars, Mars is about 1/3 as massive as Earth. So, acceleration due to gravity on Mars is closer to 3.3. Okay? So 64 times 3.3, 211.2. Okay, roughly. F equals ma, right? Okay. Weight is a measure of the force of gravity on you.
Oh.
Okay.
So
So
technically,
mass,
when they say your weight is, it's technically your mass.
when they say that you weigh 100 pounds, what they're saying is that assuming an acceleration due to gravity of 9.8 meters per second squared, you weigh this much.
But really it's your mass, not your weight.
Your mass, yes, exactly.
So
So your mass,
when they say weight, they're incorrect.
it's really mass, right? Because
Why
they're
would we say
assuming,
that?
well, because they're assuming 9.8, and then was this. Weight is the force of gravity. It's equal to your mass times your acceleration due to gravity, which is symbolized as g. So these two equations are exactly the same as each other. So F divided by m will equal your acceleration, right? So m is a measure of your inertia, or a measure of the effect a force can have on you. Weight describes the effect the force of gravity is having on